So we have software engineering. Starting off, we need to define exactly what software engineering is. But before we can do that, we need to understand what software is. When boiled down, software is the collection of instructions that a computer will execute. Some examples of software include operating systems such as macOS, word processing softwares like Microsoft Word, web browsers like Google Chrome, or even video games. Now that we have that in mind, we can define software engineering. As you can see, software engineering is the application of engineering principles to the development, maintenance, and testing of computer software. So software engineers are the ones that design and create the applications or software that we all use on a daily basis. So what major branch of engineering does software engineering fall under? Software engineering falls under the branch of electrical engineering, where electrical engineering is the application of electricity and electronics. The computers we have are built with electronics and require software engineers to dictate what is computed and how it is computed. There are many subdisciplines that fall under software engineering, so we'll look at a few. First, we have web development. Web developers are those that design and create the websites that we visit, like YouTube or Facebook. Next, we have artificial intelligence. This is a rapidly emerging subfield. AI engineers create tools and systems that automate tasks for us. This can include facial detection software or self-driving functionality. Lastly, there's application development for iOS or Android. These types of software engineers create the apps that we use in our phones. We have two example projects a software engineer could work on. First, at large tech companies like Google, there are teams for even just the smallest of tasks. If you were to work at Google, you may be assigned to work with others just on managing the functionalities of comments in Google Docs. The next example is more fun, as it is a fingerprint-based ATM system. The software engineer would have to create a database of fingerprint credentials, accept fingerprint input, validate input, and allow the user to manage their bank accounts. With software engineering, interdisciplinary collaboration is common when it is being used for applications in the real world. Collaboration is limited when the product or service exists exclusively on the internet. First off, we have car manufacturing. In modern car manufacturing, almost all of the steps of creating the cars is done with machines. This leads to a high level of collaboration between software engineers and mechanical engineers. Mechanical engineers would design and create the machines capable of assembling the cars, while software engineers would be responsible for programming the behavior necessary for each machine in the assembly line. Another area with collaboration would be creating the systems necessary at a water treatment facility. The collaboration would be between software engineers and civil engineers. The civil engineers would design the facility that is capable of treating the water, and the software engineers would create the software that manages and controls the process of water treatment. Thank you.
My name's Dave Talmadge. I'm 59 years old. I went to ASU. Got a degree in engineering, aeronautical engineering technology, and graduated in December of 1988. I've been a practicing engineer for over 33 years. Okay. I work for Mechanical Dynamic and Analysis. It's a turbine generator repair company based out of Albany, New York. Okay. The reason I wanted to be an engineer, I was in the United States Air Force out of high school. And I got to fly a few times in an F-15. So I wanted to be a fighter pilot. So I figured my best chance to be a fighter pilot was to be an engineer, an aeronautical engineer. That way I would have more to offer the Air Force relative to just being a pilot. I could be an engineer and help design planes or fix planes as well. So I went to ASU once I got out of the Air Force in order to get an engineering degree so I could pursue a career as a fighter pilot. All right, I think a very important skill for all engineers is common sense, meaning simple thing, if something's not broke, don't try to fix it. Common sense goes a long way. The second thing to have is communication skills. Third, look at how do you identify a problem and how are you going to correct that problem and do it on a timely basis. So those are three things I think they're very important for an engineer to be able to put in his toolbox.
Hey guys, I'm Miguel. I'll be going through the interview we conducted with our software engineer, and so I reached out to my friend. His name's Alex Panza. He's 26, software engineer at American Express. I asked him what a normal day looked like for him. He says there's days that he only codes, other days he's fixing production issues, other days full of meetings and scrum ceremonies, which are quick meetings with his team to make sure everyone's on the same page and working towards the same goal. I asked what programming languages he knows, as well as which ones he uses most often. He said he knows Java, JavaScript, Python, C, C++, VBA, and Swift. What's the most difficult part about being a software engineer? He said it was just staying up to date. Tech is always changing and getting better. Staying on top of what's new and cutting edge takes a lot of effort. He said the second you think you have everything figured out, something new and better is released. I asked him about collaboration, if it's important with his colleagues within software engineering. He said it's very important. When multiple engineers are working on the same project, it is crucial that they are on the same page to deliver efficiently. And I kept one of his quotes in. He said, imagine two people trying to draw a circle blindfolded. That's what writing code without communication looks like. I asked him what got him interested in software engineering. He said it was rewarding, and not just the money. He says that there's no better feeling than getting something to work. He feels accomplished after completing something, and that in itself he finds very rewarding. And he also said his family. His mom's a senior software engineer at the same company, and so he says that it probably runs in his DNA. If he could give himself his younger self any advice, he said to just put in the work and to grind. Subjects in school may not always be interesting or make sense, and it's so easy to use that as an excuse to not do your best. But he said just be open-minded and willing to learn, and it will pay dividends for the rest of your life. And he also said a lot of caffeine, a lot of energy drinks for the late and long nights during school. Just some new information that I learned from this interview is that it's worth it. He seems very happy where he's at, and it's something I want to work towards, so it makes me very confident. Self-learning is the key. He tells me that he's taught himself a lot of programming languages, and not just that, he's taught himself a lot. And it just goes to show you that, to teach yourself and being able to teach yourself, self-learning, it really is the key. Always be alert, always be on your toes, always be looking for what's new and exciting. Caffeine and lots of it. And just do not be afraid to communicate.
So some career paths that will get you into engineering. So basically to get into engineering, you have to have a history, you have to have a background of, computers, whatever, yada yada. There's many programs, especially at different schools, that will get you your degree in in software engineering, But if you don't want a degree, you can do a certificate. Those take about 6 to 12 months. I took the top 5 universities, in my opinion, for software engineering, which are University of California, Stevens Institute of Technology, San Jose State University, California Polytechnic State University, and Milwaukee School of Engineering. They have plenty of programs. They offer all kinds of degrees. You can get your doctrine in computer science and information and technology. Really great programs. Engineering societies. So an engineering society is basically a group of people. It's basically like a union but for engineers. Some examples are American Association of Engineering Societies, Institute of Chemical Engineers, American Nuclear Society. I thought that one was pretty interesting, and so on. Some internships that revolve around software engineering. I couldn't really find much information, but I did find one internship in particular. It's actually for Google, a Google internship. So I left this link here. If you go to this link, it'll actually pull up where you can literally apply for the internship. And they're all across the globe, they're everywhere, and they're paid for. These are paid internships.